Hi, everyone. Thanks for being here. As a quick reminder, IARPC is the Interagency Arctic Research Policy Committee. We bring together leaders from 18 federal agencies, departments, and offices across the U.S. federal government with the intent to enhance research in the Arctic. IARPC Collaborations is a platform that connects federal government researchers, non-federal researchers, and Arctic communities, including those overseas, to work together on pressing Arctic research issues. All of this work ultimately supports the 5-year Arctic research plan that we continually are responsible for updating. As a reminder, IARPC Collaborations is free and open to anyone who can contribute, regardless of their role in Arctic research. The website has supported an unprecedented degree of interagency communication, coordination, and collaboration, and arguably has advanced Arctic science. I am David Allen. I am the co-lead of the Monitoring, Observing, Modeling, and Prediction foundational area of IARPC with colleague Sally McFarland from DOE, Kiki Schultz, who's on the call, and David Clemens Sewell from the NOAA Physical Sciences Laboratory as well. The IARPC MOMP was established under the new strategy, the most recent strategy, and is intended to improve the integration of these 4 areas: modeling, monitoring, observing, and prediction across the entire IARPC enterprise to advance Arctic research. We have 4 different objectives and a number of deliverables under those objectives, and this discussion is focused on one of those sets of deliverables, actually several, to be honest with you. I'll turn briefly to my colleague Cindy to introduce the data management collaboration team. Cindy, please go ahead.
Sure. Thanks, David. Hi, everyone. I'm Cynthia Garcia. I go by Cindy. I'm a program manager with the Arctic Research Program, which sits within NOAA's Global Ocean Monitoring and Observing, or GOMO. I'm thrilled to introduce the data management team within the IARPC Arctic Research Plan framework. Data co-leads include myself, Lauren Decker, who's also in the call right now, as well as, and Lauren is from Pole Arctic. And then we also have a new lead. Her name is Maya Rita Williams. She's from the Indigenous Sentinels Network. And maybe she will join the call later on. The team and our members work on advancing the objectives and specific actions towards a more fair, so findable, accessible, interoperable, and reusable data, as well as to provide space to talk and to share resources about how we can also advance care principles or collective benefit, authority to control, responsibility, and ethics data principles. I'm happy to be part of this discussion and also to advance some of our best practices around this topic. And I guess I'll pass it back to David.
Actually, I will quickly toss to Richard Collether, who's the one of the co-leads for the modelers community of practice. Richard, do you want to give a couple of quick introductory remarks on the modelers, please?
Hey, thanks, David. The modelers community of practice seeks to report on Arctic research involving numerical models for diagnostic studies, application, evaluation, and prediction. We have a particular focus on Earth system models, Earth system model components, and numerical reanalyses. My name is Richard Collether. I'm with the University of Maryland at College Park. I'm located with the Global Modeling and Assimilation Office here at Goddard Space Flight Center. My co-leads with the Department of Energy are Renu Joseph and Wilbert Wire. David?
Well done, sir. Thank you so much. So about what we're about to embark on. Models continue to evolve and become more sophisticated, so do modeling outputs. Because those outputs are becoming so large, data centers and modelers now struggle to determine what information to store and what information to discard, which presents real challenges for findability, accessibility, interoperability, and reproducibility, or FAIR principles. Since some of those approaches and practices that are being developed, approaches are being and practices that are being developed in other non-Arctic spheres, we have put together several presentations that discuss emerging practices for making decisions regarding large model outputs and other good practices that could be considered. We'll have 2 speakers today who will discuss those approaches. First,
Yes.
First, Doug Schuster from UCAR will discuss tools to assist simulation-based researchers in deciding what project outputs to preserve and share. That's part of some NSF-funded EarthCube work. And then next, we'll have Forrest Hoffman from Oak Ridge National Laboratory will discuss his work with the Next Generation Earth System Grid Federation. That is an international consortium that supports Earth system science through its globally distributed network of data servers that archive and distribute climate model data. And now, before we turn to those presentations, I just wanted to give Cindy a quick note about a practice that has emerged through the data group, and this is the crowdsourced document. So Cindy, please go ahead.
Yeah, so if you're familiar with any of the data team meetings, we do have a crowdsourced document acknowledging that participants of every call are also experts in the different domain or research that you're part of. So we would like thank you, Hazel, for folks to share your ideas, resources that you know, links to established best practices for how we can address the challenges associated with large model outputs. So if you don't have access to the document, feel free to request access there, but the Google Doc is shared in the chat. You can also use this document here to pose any specific questions or needs based on your research or your domain. So thanks. And maybe we can flesh this out more later during the discussion.
Sounds great. Thank you. With that information conveyed, I'd like to turn first to Doug Schuster to give his presentation.
All right,
Doug,
thank
take it away.
you.
Thank you.
Yep, I'm just going to put a couple links in the chat that might be of interest as we move through the presentation, and then let me go ahead and do the screen share here. Okay, can everybody see this okay?
Yep, looks great.
All right, sounds good. So thanks for the invitation to join this meeting. Again, my name is Doug Schuster. I work for the National Center for Atmospheric Research, and I'm acting director of what's called the Information Systems Division. That's part of the Computation and Information Systems Laboratory, which runs our supercomputing facility. And kind of my focus is on managing some of our data services and repositories, and dealing with, how do we store outputs and what do we store? So, and I'll provide a little bit of background on this project moving forward. But the co-PIs in this project were Matt Marinek from NCAR, Gretchen Mullender, who's actually now at NCAR as well, and then Jared Markey from the University of North Dakota. So in terms of what motivated this project, well, as a data manager, and working with some of our data stewardship staff at NCAR and some outside researchers as well, we get a lot of questions in terms of, what do I need to preserve and share to meet publisher expectations for supporting data open access to data sets. And one of those topics was model outputs where, you run a model like the weather research and forecasting model that's one at NCAR that's involving into something called MPAS. And those models dump out all kinds of different outputs, history files, parameters in every file. And you're like, do we need to preserve all that? And not necessarily, but we wanted to really develop a tool to assist researchers in determining what do they need to preserve and share to support publication requirements for one use case, as well as requirements of funders for providing open access to their data and software. That's typically a requirement of a proposal. So that's a little bit of background about what led to this. So to kick this off, we had a number of different workshops as part of this research coordination network. A couple were held virtually back in 2020, and then we held a final one in 2022. And we included a range of participants, including experienced modelers from a variety of disciplines, specifically the atmospheric sciences, the ocean sciences, and the hydrological sciences. That's kind of the focus of who we talked to through this. We had data and technology experts for, dealing with different capabilities for archiving, disseminating data. And we had representatives from the publishing community as well. And then finally, we had early career representation, because honestly, they do a lot of the work and have to deal with a lot of the model data that's generated through simulation-based research. So the goals of this project were really to develop a rubric that can inform researchers in terms of what do I need to preserve and share to support publisher requirements. We'll get into that in the next few slides. This is really for specific individual researchers. It's not like a center like NCEP that's running a reanalysis or something like that. These are, project groups at universities, specific PIs that work at NCAR that might run simulations to support their research use case needs. But anyway, then according to the rubric, we developed use cases according to rubric score for reference. Basically, an example of if I get a score, here's what that looks like. Here's what other people have done in terms of what do they preserve and share. And then we discuss challenges in achieving data and software management goals in general through this project. So what to do about model data? In general, for the projects I'm talking about, the answer is to not preserve all of the data and output for all projects. It's too expensive. It's costly to preserve data for a long time, especially these large volumes. So in many cases, publishers request that data be preserved for a minimum of 5 years. So you look at the cost of storing something over a minimum of 5 years. And then models generate all kinds of information, and not all of the things that come out of a model are relevant to a specific research topic. So I'll go over some of the project findings and then discuss some of the challenges that were discussed as well in the project. But what the people that participated in this research coordination network, came up with was that it's really important. The software component is as important, if not more important in some cases, than the actual data component, depending on what the purpose of a project is. So there's a number of components to what's used to drive a simulation experiment. You have the initialization and forcing data. Hopefully, ideally, these are preserved in a community data repository, and that's the responsibility of the data provider, such as an agency. There's been many cases where individual researchers are trying to download, large inputs that are provided by NOAA or others and store them and reserve them, where that's not really their responsibility. And then all the components that are used to drive simulation work research, including pre-processing code, simulation configuration code, and post-processing codes. Ideally, all of these different components will be actively maintained in a code and documentation hosted in a collaborative development platform. So Git or GitHub is an example of that. And then you have a snapshot of the code documentation and configuration used to support your research findings archived in a community software preservation repository. So that's where you'd have a snapshot preserved in something like Zenodo with a DOI pointing to the snapshot of the configuration and code that was used to support your research that you publish in a paper. And then finally, the final component that we looked at in this project was simulation workflow outputs. And typically, the guidance is for a selection of simulation workflow outputs, and those are preserved in a community trusted data repository, and that's typically the researcher responsibility. And that's kind of where this rubric comes into play, is informing what goes into that blue box on the right. So we wanted to define a purpose of this rubric because as we work through these workshops, there are a number of steps in simulations, and what do I need to save at each step and whatnot. So you can use it, for various steps within a project, but we wanted to focus on assisting a researcher in determining what simulation outputs should be deposited in a trusted community repository to communicate knowledge that's related typically to some kind of a referred research publication. And really, when to use this is during the project formulation phase. So you can, develop requirements for software and data management as part of your project architecture. So that's where this figure comes into play. You come up with a research idea. As part of that, you formulate a simulation configuration, workflow, and computational needs that you expect for your research. At that point, you would craft a software development and sharing plan to facilitate simulation workflow reuse. And the recommendation here is one that I just went over: preserve and share all code configuration elements of the simulation workflow if possible. And then the next step would be determining what simulation output products to preserve and share, and that's kind of where the rubric comes into play. At this point, hopefully you can identify and engage a repository or a service of some sort to host your simulation output products that result from your research. And then if you're in the proposal stage, it's at this point that you can include resource needs if there's costs, for example, for long-term data and software preservation to support research by others in your budget. So a lot of times this comes after the fact. There's a lot of re-engineering of outputs that has to happen, but if you can include that as part of your project, it makes it a lot smoother and more efficient. So briefly, here's an example of what this rubric looks like. It's broken up into big picture questions. And then there's a number of descriptors that are used to basically inform that big picture question. And then there's different classes that users can select that end up informing a score for each one of these rows within the rubric. So it ranges from a recommendation to preserve few outputs to preserve most outputs. And then you come up with a comprehensive score once you work through the full rubric. And through the example rubric link that I sent in the chat, you can kind of see what this looks like. But one area, where we look at in this example is cost. Is it more cost effective to rerun a full simulation workflow or preserve model output products in a trusted repository? So that's one question that the rubric looks at amongst others. Another is, is your simulation experiment part of a broader set of coordinated experiments? So that's another one that's kind of, looks at, is it a data production goal out of your project? But first we'll look at cost. So in this case, what's the cost to produce your simulation workflow outputs? There's a couple of different descriptors that are used to inform that cost: computational cost of running the simulation workflow, and then the human resource cost of producing the simulation workflow. If it's small computational cost, no special platform needs, trivial effort required to replicate simulation for most end users, the recommendation is weighted towards preserve fewer outputs because it's relatively straightforward to rerun the simulation. Class 2, it's kind of in the middle, moderate computational cost, easy access to needed platforms. And then class 3 that weights the rubric score towards preserve most simulation outputs is, what you would expect: high computational cost, maybe you need resources on a high performance computing platform, significant human resource time and expertise required to replicate the simulation. So in that case, it's weighted towards preserve more of the outputs because it's hard to rerun the simulation. So on the other end of the spectrum, what's the cost for you to archive the output in a trusted community repository? So this has one simulation descriptor in this use case: a repository supported data curation costs. If the expenses are prohibitive because of whatever the factors are, including large volume of the expected outputs, the rubric weights the recommendation towards preserve fewer outputs. You have the middle use case once again. And then finally, if it's inexpensive or resources to preserve outputs aren't really a consideration, then the rubric basically weights the score towards preserve more outputs. You have a number of these different rows in the whole rubric that you go through to get a final composite score. And there are 3 different bins that the RCN came up with for how that score works: to preserve few simulation workflow outputs, selected outputs, and the majority of outputs. And most of the use cases we worked through, it came into this middle bin of selected outputs. And then tied to each one of these bins, there's a reference use case with some documentation and description information on how others have approached this. So just for some examples, for the preserve few simulation outputs, typically idealized process studies fall under that category, where the goal is knowledge production, most values in model configuration and codes. An example of selected simulation workflow outputs would be an ensemble forecast experiment, where for others that want to do downstream reuse, typically the most important fields for their reuse and for informing the research are summary files or statistics that are compiled as a result of the ensemble simulation. And then finally, there's a third category where it falls under, what we characterized as a data production use case, where the goal is to produce data for downstream reuse. So you have a lot of follow-on research based on whatever your simulation output is. So a few additional findings, then I'll wrap up here. One challenge, in dealing with these large model outputs is sustainable curation. So that's kind of where we got into the software and data management plans need to be well thought out and elevated in importance by funding agencies. This really has broader impact if you want to think of it like that, not just an afterthought, which it is in many cases. And then funding should come specifically for data and software management needs. Currently, this is kind of implied if you get funded for a proposal that you need to do this, but it's just part of the general research budget. And then hopefully, researchers are somewhat familiar with training for data and software management. Another area of discussion that came up is what's the lifetime for simulation products, simulation data products. So typically these do not need to be preserved indefinitely. They're not an irreproducible measurement that happened at a point in time, and typically they're superseded by newer products that come as advancement happen, with models and different technologies. But for this to be the case, there needs to be a strategy by a repository or whoever's managing the data to advertise the deaccession strategy and how that works, and have a defined process to evaluate when simulation data can be purged from a repository. And this feeds back into sustainable curation. And then in general, we need to incentivize data and software preservation and sharing. So typically in the atmospheric science community, at least, we've been rewarded for hoarding data and software and producing as many papers as we can off of our hoarded data and software. So we need to kind of reverse that. Basically what's been going on with that in terms of culture. And then finally, we don't want to exclude communities from participating in open science practices because they don't have the resource needs really to support the requirements for data and software curation in terms of, modeling studies and other studies. So they need access to resources that can support basically preservation of data and software like we do at R1 institutions. And there were some ideas in that that were expressed during the RCN. So just wanted to highlight that this product's been used in guidelines for the American Meteorological Society as well as the AGU. And then I put the link to the interactive rubric in the chat earlier. So that's all I had today. So thanks again for giving me the time to present. I'll take any questions that you might have or we have time for.
So first off, thank you so much for that great presentation, Doug. I think we'll do questions and answers at the end of both presentations. So we'll what I'd like to do right now is turn to Forrest Hoffman to give his presentation on the next generation Earth System Grid Federation distributed data infrastructure. So Doug, if you would, please go ahead. Sorry.
Thanks very much, David. I wanted to talk today briefly about the Earth System Grid Federation, or ESGF. A lot of people know what ESGF is, but don't remember what it stands for necessarily. But really, this federation is a larger international consortium working on, right now, developing a new generation of the hardware and software infrastructure. And I'll talk a little bit about that after a brief introduction. Here in the US, DOE, the Department of Energy, is sponsoring the largest ESGF development project right now that I'm aware of, which is this ESGF2 US project. And that's supported by the Biological Environmental Research Data Management Program in the Earth and Environmental Sciences Division. And that's led by Dr. Jay Nilo. So what is ESGF? Well, ESGF is, again, as mentioned on the previous slide, this international consortium, but it also represents a globally distributed peer-to-peer network of data servers that use a common set of protocols and interfaces to both archive and distribute climate and Earth system model output and related input data sets, observational data sets, reanalysis data sets. A lot of these other ancillary data are becoming increasingly important. Again, all of the data are open science data, and they're used by scientists all over the world to look at Earth system variability and feedbacks and to inform the development of things like assessment reports. Down at the bottom are logos from US agencies that have some stake or investment in ESGF, as well as a European group that was formerly part of this Easiness project, and then the Australian National Computational Infrastructure. As mentioned in the introduction, we all like data to be fair and open, so findable, accessible, interoperable, and reusable. And we really try to take this to heart with these model output data because we'd like them to be accessible to the entire world so that they can understand and apply them to their own research. The last activity was CMIP 6, and before that was CMIP 5, and that CMIP 5 activity generated about 1.5 petabytes of model output, some of which was replicated, and if you counted all of the replicas in there, it totals about 5 petabytes. With CMIP 6, we're closer to 16 petabytes now of data. Not all of that, probably about half of that is replicated in the US. But with all the replicas in Europe and Asia and the US and Australia, it represents closer to 30 petabytes in total. For CMIP 7, we're expected to have many more experiments, higher resolution output, more ensembles, and an initial guess at this was that the total might come to around 100 petabytes. So when we get to that scale, we have to start thinking about what kinds of resources across the international community can fully support that scale of data. We're real concerned, of course, with security and integrity of data, but access to the data is open. So it's nice to be able to work on a project like that where if somebody really wants to hack in and get your data, that means they want it for something. So that's good. We now have a new MetaGrid interface, and I think I posted a link to this in the chat already. But it replaces an old interface, so it's a nice multifaceted search interface. So if you're familiar with all of the facets, it's great. If you're not, then you have to do a little learning up front. But we're also thinking about how to develop better data discovery interfaces. But this has a lot of advantages over previous interfaces in that it offers a shopping cart where you can sort of aggregate the data you're interested in. You can save searches and share them with other people. And we've now got Globus integration for fast unattended data transfer. So you can just say, take all of this data and put it on that supercomputer over there and send me an email when you're done. That helps a lot. This is a very US-centric view of ESGF, but right now within the Department of Energy, we have 3 main sites located at Oak Ridge National Lab, Argonne National Lab, and Lawrence Livermore National Lab. We're in the process of migrating those data resources at Livermore over to NERSC, which is at Lawrence Berkeley National Laboratory, where we already have a pretty significant data lake of CMIP 6 model output. But we work hard to replicate data from the Worldwide Federation, so from all of these other sites that you see at the bottom, for data that's daily or lower frequency. We don't get the very high temporal frequency unless there's a need to do it to support research or a group. But then JPL, NCAR, and GFDL also are operating nodes. Within the next generation development, we're moving to hosting our indexing and search capability out in the commercial cloud, and this we think will improve reliability and accessibility to the data. Within DOE, of course, we're leveraging this Earth Sciences Network for global connectivity. So thanks to some really big physics experiments in Europe, we have really high-speed connections over there, but also very decent connections to other parts of the world and pretty high-speed connections amongst the Department of Energy laboratories. Yeah, so historically, Lawrence Livermore has operated the primary ESGF node within DOE. But because of changes in the project and our desire to preserve the data and to replicate it, we a few years ago actually made copies of this 7.5 petabyte data collection to Argonne and Oak Ridge National Laboratories. We used Globus scripting to transfer all the data over ESNet. And the upshot of this is that, you know, we had about 17 million directories and 28, almost 29 million files to move that we moved between mid-February and May 4th back then. We learned a lot about doing these large-scale data transfers. And so it took us about 3 months to do. But if we hadn't run into some problems and challenges, we probably could have done it in 2 months. So that's pretty good for this scale of data. And we were achieving almost 8 gigabytes per second data transfer speeds between Oak Ridge and Argonne there. So we moved the data out of Livermore once and then synchronized across the other 2 sites. So that gives us a nice replication of the data at 3 locations across the US. We'll see if we can preserve that going forward to the next set of CMIP data. But all of our development has really been centered around use cases like this enabling use case where Samantha is interested, for instance, in using her institutional credentials to look at new data, code, and papers relevant to her current research. She finds a report on extreme precip events and examines a Jupyter notebook that implements that method, and then wondering how the method might work with higher resolution data from another model like E3SM. She quickly locates some required data sets and runs a notebook on a subset of those simulations. Because she's intrigued by the results, she shares them with collaborators via ESGF, and they agree to that a much larger simulation ensemble analysis is required. So she initiates a large-scale simulation with multiple ensemble members, and within, say, a day, may have the results back and published on ESGF, again, for broader consumption by her and her colleagues. So this is kind of a motivating use case where we hope to develop all the technology underlying this. So a lot of the core pieces are already in place, and we'd like to make these workflows easily usable and accessible to the research community. And in that regard, we're looking at how we can build a better data discovery platform, something that's a little more user-friendly on the front-end side, but then to use the databases and search capacity that we're expanding now through the cloud-based index to be able to find the data of interest. We're also developing server-side computing capabilities right now to allow for subsetting and data filtering, conversions, generation of statistical summaries that would all happen on the server side so that the user doesn't have to download data or access the primary data sets in order to get this information that they actually need. We're expanding options for data access. As I mentioned, Globus already is one of those key ones. We're still supporting OpenDAP as well as HTTPS. And we're testing right now and about to deploy a user computing platform to do analysis and visualization. And this sort of Jupyter Lab concept allows us to host users who want to come on and do their analysis right within the data system that has direct access to the ESGF data. That way, the user doesn't have to download the data to their own platform in order to use it. They can just conduct their analysis here, save off their Jupyter notebooks and their analysis tools to GitHub or some other facility, and still be able to come in and replicate and continue to do their work, what we call computing at the data. In the last few years, we've developed additional capacity at Oak Ridge National Laboratory through investments in the National Center for Computational Sciences here, who are operating this cluster that we call Onyx, that is a Kubernetes-based cluster All of the ESGF platform runs containerized within this system. So it's a high reliability system that automatically migrates tasks around. And the data are stored in a new hierarchical storage platform. So we have about 15 petabytes of disk and 30 petabytes of tape, which are about half full right now. But this way we keep data spinning for at least a year. And if it's not touched, we ensure that there are 2 backup copies on tape, and then we can remove it and free up additional disk space for new data that come in. And we plan to expand that. I already mentioned in this multifaceted metagrid interface, search interface with a shopping cart and nicer capabilities, and that Globus integration that's now turned on across all of our sites. We have a variety of outreach activities that we've done. We do some webinars and tutorials, boot camps. We've had a couple of hackathons. We tend to hold workshops at AGU conferences, and so we're happy to have people participating there. One of those is not listed here. And then we have, in the last couple of years, resumed these developer and user conferences focused around bringing the federation teams together from Europe and Australia and Japan and the United States for the continued development and implementation of this next generation platform. The last one of those was back in April in Rockville, Maryland, where we had about 50 in-person attendees from 8 countries and about 69 virtual people from about 18 countries. So there's broad interest in where this is headed. And we there developed a roadmap for new infrastructure that's centered around this data backplane infrastructure and this new indexing strategy for data search, where we would have a Western index and an Eastern index. They're kept in sync by a federation-wide event stream, so that as data are published onto ESGF or replicated there or retracted from modeling centers, we can have certain services that get initiated to move data around, replicate it as needed, perform any other checks, or generate value-added products from that. And this is a really resilient system, because if for some reason one of these indexes becomes unavailable, the other one can take over. We're also ensuring that we can replicate the indexes to other locations around the world should we need a third or a fourth large-scale global synchronized index. But we also find that this federation-wide event stream is becoming increasingly useful just in concept so far, but we're very near completing deployment to keep community activities like those who operate their own little data lakes in sync with what's going on with the primary publication activities within ESGF. So in summary, all the ESGF development is performed collaboratively with Federation partners. That makes it a little bit slower, but it makes everything better and ensures that that multiple people on multiple continents know how to use and develop this architecture. We've added new data projects. There's a recent one on downscaled climate projections, in particular LOCA 2 and STAR ESDM. And we're thinking about developing additional capabilities to host large-scale data for machine learning training, large ensemble simulations, model intercomparisons, and more data for model evaluation and benchmarking. I mentioned user computing with this Jupyter Hub environment. A lot of this effort was started off in the commercial cloud and deployed through utilizing a lot of, for instance, S3 and ZAR formatted data. We hope to do similar things to support the community and leverage the knowledge and experience that was gained there, probably through an on-premise cloud infrastructure to enable this computing near the data. I already mentioned the shared indices. We have now a unified federation authentication through Globus Auth on our side and EGI check-in through the European side. And these are all compatible with each other, so you get to choose based on the platform you go to how you authenticate, and it can authenticate to your own institution. We're integrating software stacks for data access, analysis, and visualization. We are working on managed automation of data publishing through Globus Flows. I skipped past the Globus search, but this scalable data index that I mentioned in the previous slide is actually using the STAC interface, the spatio-temporal asset catalog. And underneath, the technology can vary. And then again, I mentioned server-side computing. So we're already doing some of that with web processing services, and we're experimenting with Globus Compute as another enabling capability for offering these value-added products and subsetting and summarizing data. So that's what I have for today. Thank you.
Thank you so
Well done.
much.
Go ahead, Kiki.
Oh yeah. So yeah, I haven't introduced myself yet. I'm Kiki Schulz. I'm one of the co-leads of MOMP, and I'm co-organizing this webinar. And I hope you all found it as interesting as I found. It's like so much data, right? And we do have time for questions for the next like 10 to 15 minutes if any one of you has questions. And I'm trying to moderate it a bit. And if you want to put your questions in the chat, then I'm reading them out. Cynthia, please. Thank you.
Thanks, Kiki. Thanks, Forrest and Doug, for your excellent presentations. So my question is to Doug. So Doug, your rubric really, I think, provides a great framework for deciding what simulation outputs to preserve. But I'm interested in how this translates specifically to data management plans. And so, we require DMPs for research projects, but we struggle with consistency in how modeling outputs are addressed. So do you have any, concrete recommendations there on how we can integrate your rubric in DMPs and the review process? And are there examples of groups that have successfully embedded this or some similar decision tree framework into their formal DMP requirements? Thanks.
Yeah, so there is a group actually, I think out at Lawrence Berkeley with ESS Dive that actually has forked this and used it kind of in their own use case. So the rubric, it's kind of its own, it can be, like you said, a framework that others can fork to use and tailor as needed for their specific communities. So that's one example, and I don't have it in front of me, but I can pull that up. They actually have a paper on it. In terms of using it, as a sustainable tool moving forward, ideally we'd have a community or somebody pick it up and host it as something that looks more like a survey. And we had an example of that through the third workshop, I think, that somebody can, basically fill out these questions and come up with a score and get a printout. And then you can cite that as a reason why you decide to say, my estimated volume in my data management plan is going to be 20 terabytes. I'm just saving surface temperature outputs or whatever. And that's what we've, based on the guidance from this project, we feel others will be valuable for others to reuse. And that's in addition to hopefully preserving and sharing all of the code, like I mentioned in the project. So that's kind of how we envision it, as something that can be cited to be used to justify what somebody puts into a data management plan. And if they're going to preserve, I'm going to preserve 20 terabytes versus the 100 terabytes of raw data that comes out. So I'm actually saving this much money by doing that in the long term as well.
Thanks.
Yeah. David, do you want to go ahead?
Sure. So thank you both for the great presentations. I've been looking forward to this for months now as we've been in the planning process. I wanted to ask Forrest a question about the sort of rules of the road of, well, two questions. One is about the rules of the road. One of the things that seems to be a potential challenge for an enterprise like this, which I think is incredibly laudable on its face, is that is understanding it takes a long-term commitment. And I wonder what the partners have sort of committed to in terms of preserving this information. You talked about the management of the information on a sort of annual basis, but I would be curious to hear some thoughts on that. And then the other challenge that we constantly hear in IARPIC circles is this issue of access for users in rural communities, particularly obviously Arctic communities in Alaska. And I wonder whether there's any line of effort to sort of improve or preserve access for folks in more rural, lower bandwidth communities as well. So thanks.
Yeah, sure, David. Yeah, you're right. I mean, committing to the long-term preservation of these model data is difficult. Um, you know, in Doug's rubric, where he said you have to analyze the cost of running a simulation again versus saving all of the output. And in the cases of many of these models, they're very, very expensive to run and very challenging to run. So you probably wouldn't run 30 ensembles of, some of these 200-year simulation experiments again. And in fact, they tend to run on machines that are very high-end machines that get replaced frequently. So in fact, you may not be able to run that simulation again after, say, 3 or 4 years. And at least not the same one. And so we try to keep that in mind. But the other thing is that these CMIP activities happen on sort of a 7 to 8 year time scale repetition. And so obviously we want to preserve our data for more than 5 years. And we would like to achieve something like a 30-year kind of time scale for the at least medium frequency to lower frequency model output. And that can be challenging as well, as you can imagine. We are currently looking at this next generation data search capability and architecture. And we're talking about, because of the complexities of the changes in how the data are represented in the index, we're talking about not necessarily adding in CMIP5 data to the new index, which doesn't mean it goes away. So the data we will keep. It just may not be as easily searchable from the next generation architecture. Here in the US, we're developing something we call ESGF like 1.5 before you get it to a 2. So we're replacing that back-end search engine with a commercial cloud-based technology in order to mimic the existing system. And so we expect to run that for a couple of more years as CMIP7 comes online so that we can continue to provide easy access, not to the previous generation, which will be migrated, but to the previous generation data, which will be kept on multiple continents, but will be searchable on a longer time scale from our own site. And so those things definitely require investment and time, but I think it's worth it to offer that capability to the community. So if you can continue to provide that ease of access, then it's good. At some point, this becomes, what looked like a really big CMIP5 activity becomes something that looks kind of small, right, compared to CMIP7 or the next generation of CMIP8. And so the other thing that we are providing is direct access to the data hierarchy. So you can log into the system and actually just go through the hierarchy and find what you're looking for without that search engine capability. And then before we get to Richard's question, I wanted to answer your question about other communities. So there has been some investment by the Department of Energy in data infrastructure at the University of Alaska Fairbanks. And that's how we hope to engage at least the US Arctic communities in providing faster access to data. That still requires some infrastructure. I'm not sure of the status if that's a fully operating, containerized node yet, but I believe that was the intention in that investment. So hopefully that's occurring. But CMIP and these international activities are actually thinking about things like the Global South. And how do we get it to African communities, and how do we engage them not only in analyzing model output, but in being able to model some of their own regional impacts. And so there are also activities that we're at least consulting on for engagement in African communities, and Southeast Asian communities, to try to get infrastructure into the hands of those folks. We can't send it to them directly, but we can support them if they can get some support to run our packages. And we want to be sure that they're easy to access and portable. So all of our development also works in commercial cloud type infrastructure. so that if they have access to something like that, where they're not operating their own supercomputer in the heat of an African desert, they can still be able to access infrastructure through commercial technologies like that.
Richard, you want to go ahead?
So I have a question for Doug. So looking through your rubric spreadsheet, it looks like the community commitment question could be one of the most challenging to understand. Some of the other criteria that are given on that line are, whether you're part of a larger intercomparison group or something like that. That might be a low threshold. I don't know if that's necessarily guidance for answering that question. I was wondering if there's been significant research on how people have used legacy model archive data and its effectiveness. Has there been any research on who is using what?
So maybe Forrest has some insight from ESGF metrics. At the Research Data Archive, but that we maintain an NCAR, so that's my other job, is kind of maintaining that. We track metrics, and really what we host are reanalysis model outputs primarily. And when newer reanalyses come along, like ERA5, there's typically a big drop off in prior reanalyses. And in terms of how we're going to manage that, we're kind of looking at metrics in terms of usage, et cetera. And we do have a limited resources. We don't have indefinite money to store these things forever. So we have to go through a process and say, what are we going to take offline? Because, should people really be using NCEP NCAR reanalysis as an ideal product for modern research anyway? They might do that because legacy codes point there, things like that, or, so we're kind of working through that right now, is what do we take offline? But in terms of research and impacts of legacy model products, I don't know of any specific use cases. But in terms of that top community commitment theme, what we're trying to vet out of this is this a project like CMIP or ERA5 where this doesn't really apply, this rubric? It's part of a lot larger project where the intention is to produce data and you have resources to store that data and share it in a way that's scalable for a long time period.
I could say some things about data reuse. Within the CMIP organization, at least within these simulations, there is great interest in trying to understand how the models themselves are evolving. So there are a number of activities that are focused on model evaluation and benchmarking. And we like to have multiple generations of these models and use their output across similar kinds of scenarios, and especially of the historical period where we can compare it with observations, so that we can see how or where the models are getting better or worse as they evolve over time. So these modeling centers in various countries make large investments in the development of models and improving process representations. And so there's an increasing amount of observational data that we can bring to bear to confront these models. And so it's good to repeatedly do this sort of thing. So we did this with some platform that we've developed, comparing CMIP5 versus CMIP6 models, and we ended up with a figure in the sixth assessment report that describes that. And we plan to do that again. So we still want that CMIP5 data, right, that ran similar scenarios that will be similar to what we're going to do in CMIP7, so that we can look at what those investments in improving the models has shown. One thing that we saw on land was that, models were getting closer to the observations in CMIP6, which was great. They were more consistent, but many of the variable to variable comparisons, or these like functional relationships, are the things that improve the most. And that indicated to us that the models are getting more of the right answers for the righter reasons, right? The relationships within the model are better representative of those that we see in observations. And so I think that kind of information is very useful for model development teams and for scientists as a lens through which to look at those future projections.
And I'll
Thank you.
quickly add, just at NCAR, you know, we have to deal with a lot of this legacy model data or model output, and there's a fixed resources once again. So it comes down to a cost benefit analysis. Are you willing to spend the money required to preserve this for another 5 years at a rate of, you know, whatever it is, dollars per terabyte per year times terabytes times the number of years? So it comes down to that as well.
Thank you both so much. I want to draw everyone's attention once again to the crowdsourced document where we also listed all the resources that the speaker provided. Thank you so much for that. And yeah, I also wish we had more time. I have a ton more of questions, but we're approaching the top of the hour. So let's thank our amazing speakers again. Thank you so much. Thank you everyone for participating. And Hazel, do you have any final remarks to close the meeting, or shall we? I'm terrible at endings. Thank you all.
Yeah. Just a reminder that the meeting recording will be available on the IARPIC collaboration site. And if you don't already have a membership there, I encourage you. It's IARPIC, IARPC. Yes, IARPC collaborations.org. And you can make a membership and stay tuned for other similar interesting events and talks. So I hope you join us there and look forward to seeing you soon. Thanks, everyone.
Thanks so much, everyone. Look forward to future discussion.